So now, which brings me to introducing our next two speakers. We are very excited to have Miyoung Shin and Lorenzo Tilve. They are both working as software engineers at Igalia. Shin is a developer specialized in web platform development with experience with WebKit and Chromium on various embedded devices. And Lorenzo is a software engineer with years of experience on the Igalia web browser team, participating on different projects on Chromium and WebKit. So we're really grateful that you guys have joined us, and I'm going to hand over to you and then pop back in about 25 minutes with the questions. So over to you.
Hi, so in the first place, thanks for having us here. It has been really a pleasure to hear everyone else before us. All the talks were very interesting, and here we will be trying to explain a bit which is the status of some Chromium features and how work is being done in order to strengthen the ecosystem with some functionalities useful for content blocking. So our plan is to introduce a bit ourselves and the work that we are doing, and then explain a bit these new features that are happening inside upstream Chromium. And we will be focusing on a couple of them, specifically adding remove CSS API in order to interact with the injection of style sheets into the extension API. And my colleague Shin will be explaining into detail the whole process to have access to closed shadow root and what were changed to add a new API to access that. And we will be talking about what is the status about those functionalities and more ongoing work and what is been happening in this regard. So in the first place about us, we are Igalia. So we are an open source consultancy, and our headquarters is in Galicia in Spain. We are currently 90 employees, and we are all over the world distributed. And our main area of expertise is basically browsers and web engines. We have been working for many years in Chromium and WebKit and Firefox and WPE. So we have been actually like the second most active contributor after Google and Apple to Chromium and WebKit respectively. And we have also teams working on the compiler side and JavaScript engines specifically, and graphics, multimedia, and accessibility. So we are also members of the W3C, and we are chairs of the ARIA working group, and same for ECMA JavaScript TC39 group. So basically, we have been working on web engines for a long time and managed to get like a lot of owners and reviewers on both projects. And that's the reason why we are also trying to help on working on upstream things, and some of them are very interesting for the ad blocking community. So examples of these new features that are interesting, I will cite a few of them that are these ones that I was mentioning. We will be going a bit into the detail on how this was implemented and the whole process of review and integrating these changes into Chromium specifically. Related with remove CSS, with adding a new extension to open or close shadow root. And there are also other functionalities that are happening upstream, as the capability of add content strip to about and data URLs that has been merged quite recently by some work by Devlin that is also here. And I also want to thank him for also the work we are doing together in the community. I mean, Chromium community is really a pleasure to be working on, and some of this work that we have been doing happens because the collaboration of many different owners and reviewers in different parts of Chromium. And yeah, there are many more. I mean, of course, there are things happening in dynamic content script support. There are things happening in Manifest v3 and the JavaScript world, but we are focusing on a couple of very specific examples that can be tracked up. So with regard to the need of tabs remove CSS, this was actually coming as something that was interesting because a way to hide blocked ads in some scenarios is by injecting CSS rules through insert CSS from tabs API. But however, this is allowing to change elements that were happening. But as the DOM is changing dynamically, it's also necessary to be able to manipulate that in Chromium to also modify the visibility of elements that are varying. So bring back visibility to some elements, to remove that. And there was actually not that API that was covering the spec implemented in Chromium, and it was already available in other engines. So actually, there was an open upstream in Chromium for some time to request this method to be added. There was also an initial changelog added for that that was started by Manish Yatani, but didn't make it to upstream, got discontinued. So basically, what we were doing here was to take over that bug. It was actually done by our colleague Antonio Gomez, that was bringing back the issue to activity and was updating the original changelog to use the new APIs. It was also requiring to create a separate issue for adding an extension modification request in the API to add that functionality. That was already adding some new method to the existing one. It's different to the other case that Shin will display in detail. We were adding there the necessary tests, and after the iteration in the review process, it got landed. So this is slightly different to the implementation that was happening in Firefox, because this is adding a new security restriction that extensions can only remove the injected CSS that they were doing on their own. So what has to be done to actually implement this new method on the API? So you will have, you can see the upstream. I mean, everything is open in the development of this work, but you can see that in the changelog, what happens is that tabs JSON file adds the definition of a new method, a new function, with a description of what it's going to do, and specify a new set of parameters, what are actually the ID of the tab on which the CSS should be removed, and a new object with the specific details of the CSS and a callback to be handled from JavaScript when this removal happens. So it also needs to define the object with injection details that basically, again, has the description, the selector that has to be removed, and the file that is going to be used, and a couple of params to identify it should be removed from all frames or just the top one. So also taking into account the implementation, this what has to be done is also been providing coverage with some tests that are JavaScript files that, in combination with some preset HTML elements, it's actually verified that that's what it should do, and doesn't that, and it's not allowed to do other things that should be happening. And actually that, when it's getting merged, it produces the documentation of the extension API. So you can see that actually now it's already possible to both inject CSS and remove CSS with this new extension and the code that has been merged upstream on the code. So maybe I will handle on to Shin, and she will be explaining Shadow Root Access API.
I'd like to take a deeper look at one of the examples, which is related to the shadow root. What is the shadow root? An important aspect of the web content, web component, is encapsulations. Being able to keep the markup structure, style, and behavior hidden and separate from other code on the page, so that different parts do not clash, and the code can be kept nice and clean. The Shadow DOM API is a key part of this, providing a way to attach the hidden separated DOM to the element. You can affect the nodes in the Shadow DOM in exactly the same way as a non-shadow nodes. And the difference is that none of the code inside the Shadow DOM can affect anything outside it, allowing for handy encapsulation. You can attach the shadow root to any element using the element.attachShadow method. This takes as its parameter an options object that contains one option, mode, with a value of open or closed. Open means that you can access the shadow DOM using JavaScript written in the main page context. So element 1 shadow root returns the shadow root you attached. Closed means that you won't able to access the shadow DOM from the outside. So element 2 shadow root returns null. Why we need to access the closed shadow root, even if the spec specifies that it should return always null? First, that's precisely because it would be easy for page authors to circumvent blocking as by using the closed shadow root. Second, extension APIs works on the user behalf, so an extension app should be able to modify any part of DOM. Third, it's a little bit more complicated, but there are already existing workarounds using extension APIs to access the closed shadow root. Fourth, closed mode simply prevents outside JS from drilling into the element internal DOM, and it's not a security feature. Finally, Firefox also supports element open or close the shadow root API to allow access of the closed shadow root. Therefore, there is a sufficient justification for the need for this feature is necessary. Initially, this feature was implemented to have the same prototypes as a Firefox. And the API was defined as web IDE, as in other web APIs in Blink. But API should not be exposed to the general web, and it should be exposed to only isolate content script of the extension app. There is the Chromium process to launch or change the feature in Blink for new feature incubations, for implementation of existing standard, for feature duplication, and for architectural changes. The patch implemented in Blink was also required by the reviewer, whether intent shipment is necessary for this case to Blink dev group. And there were two main concerns from Blink dev discussion groups. One was that this approach will pollute the namespace and it can cause potential issue in the future for web standardization efforts. Another was that web IDE has a lack of properties for custom. Even if I added the new property exposed for word syntax to web IDE to only expose the API for the isolated content script, web IDE owner thought more functions were needed for general customization. I hardly understood and agreed with these reasons, especially first reason. So it was agreed to add the feature with the Chrome namespace. Okay, let's implement it again. Adding API to the Chrome namespace means adding API to extensions. And here is the detailed information on how to propose the new API for extensions and how to implement it. Although the article is described in great detail, I need to refer to other patches to understand some unfamiliar terms. And I want this presentation to be referenced to others as I was. Before implementing a new API, it has to go through an approval process. This approval process helps ensure that the API is well-defined, does not introduce any privacy, security, or performance concerns, and fit in with the overall product vision. You can fit in the required information to the providing template and send the email with the proposal to extension-api-reviewers at chromium.org for increased visibility and any additional feedback. Chrome provides detailed guidelines, so it won't be difficult to write the template. What I did actually do for the implementation in Chrome. First, I specified the DOM namespace and open or close the shadow loop method with the JSON format. And this file describes the API and the functions, events, types, and properties it contains. Extension APIs can be specified in either IDL or JSON. During compilations, all files are converted to JSON objects. The benefit to using JSON file directly is that it is more clear what the JSON object output will look like. IDL, on the other hand, is typically much more readable, especially when the API will have many methods or long descriptions. However, IDL is not as fully featured as JSON in terms of offsetted properties on different nodes. So if you don't have any special reason, you'd better use JSON. The actually C++ implementation added in extensions-renderer path. Keep in mind that the API exists in the path of the renderer because it needs access to the DOM object. Typically, the C++ implementation will live in extension-browser API or Chrome-browser-extension API path. API features specify the requirements for API availability. If the extension doesn't satisfy the requirements, the API will not be accessible in the extension code. The channel property specified a maximum channel for the feature availability. Offsetted values are a single string from trunk, canary, dev, beta, and stable. DOM namespace has a dev channel and will change it to stable channel after maturity. The context property specifies which JavaScript context can access the feature. All API features must specify at least one context, and only API features can specify context. Offsetted values are a list of strings from blessed extension, blessed web page, content script, extension service worker, lock screen extension, web page, web UI untrust, and unblessed extension. DOM namespace has the context value as a blessed extension and content script. The blessed extension context refers to JavaScript context running from extension process, such as background.js, extension pop-ups, and app windows. The content script context refers to JavaScript context for the extension content script. This feature doesn't require the permission and manifest entry and behavior availabilities, but you would need them. Permission features specify the requirements for permission availability. If the extension doesn't satisfy the requirements, the permission will not be granted and the extension will have the install warning. Manifest features specify the requirements for manifest entry availability. If the extension doesn't satisfy the requirements, the extension will fail to load with the error. Behavior features specify the requirements for miscellaneous extension behaviors. This should typically not be used. Okay, now how can you use this feature? It's very simple. You can get the open or close the shadow root as the return value of chrome.open or close the shadow root method with the element parameter. Loren will share the release schedule and future plans.
Okay, Shin, thanks for explaining. So just to wrap up before going to some question and answers part. So which is the status of these couple of functionalities we have been working on? So for the case of Chrome tabs remove CSS, it's already available in beta channel and should be making it for stable 87, as the documentation and everything is already in place. Should be usable like very soon directly. And the case of Chrome DOM open or close shadow root should be available in dev in 87. And if everything goes fine, and should be making it in stable in 88. So what next? As these were the cases of a couple of elements that were already adding new APIs to the extension side of Chromium, we were also looking forward to move some elements that were already part of CSS4 selectors specification that could be used for element hiding. So we are actually working on a prototype for has pseudo selector that has been there in the specification for a while, that has some things that have to be deeply investigated with regards to performance and the way that could be work under invalidation circumstances. But in any case, we are working on a functional prototype to get the work moving from there on. We have been also working on some other pseudo class that were not implemented in Chromium, but were available on other browsers, as having Deer pending implementation that is already in states that is going to be ready to intend soon. There's also other ongoing work in this regard that was complex not pseudo selector that actually very recently it was announced that Google was moving forward and intend to ship for that functionality. And besides that, and what has been the other type of API missing parts to be like making a smaller this gap with other browsers and adding functionalities, there are also additional things that are happening upstream and that are making lives easier in a way for content blocking, in order to have like even more selectors or things that happen on the JavaScript side, incoming new JavaScript TC39 implementation that could make it for stage 4 as realms, web bundles that were also mentioned in other presentation, and yeah, many other things that happens in a project as big as a web engine, as in this case of that Chromium is. So this was basically all from the presentation. So we will be happy to answer any doubt or comment.
Thank you both so much. There were a few questions popping through, so we'll get through probably one or two and we'll pop the rest in the Slack channel. So the one is, did you consult and align with existing implementations of tabs remove CSS in Firefox? And then on top of that, do you have plans to contribute to Gecko?
Okay, yeah, with regard to the status of remove CSS in Firefox, we were actually initially trying to provide the same functionality of the Firefox API was providing. But then this issue with regards to security was raised up, so it seemed reasonable to add this encapsulation level of security. So yeah, it's something that we have not done, but it's actually something that we could be eventually taking a look to make that as also available to contribute it to Gecko too. So it actually seems like a interesting functionality for any of both of them to avoid intersection between extensions doing that.
Thanks. Then the next one was, do you think platforms, browser platforms, web platforms, etc., have typically really considered the ad content filtering use case seriously when thinking of and writing their specs? And that's from Shwetank.
Well, the thing is that in the end, content filtering is something that is more related with more scenarios that actually happen in many cases when working on a web engine. I mean, it's in general, I wouldn't say that content filtering is like a specific use case when writing specs for web engines, but it's more like whatever any content producer can actually do, and what generic type of extension would be willing to do to avoid that. I mean, in the end, there are many scenarios in which a content producer wants the website to react to some actions that happen when loading the element, and an extension actually want to overwrite prototypes to do that. But for many different use cases, that is, I mean, not only ad blocking. So ad blocking would say that it's in general a very specific use case of proper and secure JavaScript and rendering and implementation of web engines in particular, when doing good practices of that.
Thanks. Shin, was there anything you wanted to add? No. Okay. Just checking. And then we've got a teeny bit of time left, so maybe I can sneak in the last question in the last 2 minutes. From Peter Lowe, how common is the use of shadow root inserting ads? Either of you.
Okay. Actually, I didn't see the much case in personal, but we really need these functions because ads can hide behind the shadow root. So that is what I can say that.
Thanks. Thank you both. And that looks like the questions are done. So all that's left is just to thank you once again so much for your super insightful talk. And people, I guess, can engage with you on Slack if they have further questions. And we'll be back in a minute and a half with the next speakers.
Absolutely. Thank you.
Thank you.
Thank you.
Thank you. Bye.